Alrighty then, it's part 8, and we're in neural tissues. And now, at this moment, we're going to consider the idea of neurotransmitters of a wide variety and order. And of course, we're going to deal with pretty much a short list, since we have in your body and mine 50 trillion cells talking at exactly the same time, because they're all alive and they have homeostasis. And it is a, shall we say, a necessary factor that we have coherent internal dialogues. So this is an aspect of the dialogues. Okay, and neurotransmitters and hormones actually have almost no difference at this point in the minds of biochemists and cell and molecular biologists, because the blur is in. These substances also can exist in many locations and have many outcomes based on pool of neurons or circuitry they're involved with. Okay, and I think the best example of this, where one thing has entered into multiple situations, would be acetylcholine. Acetylcholine is one of the most common neurotransmitters. It's what makes our muscles work. So when you want your arms and legs to function, you rely upon acetylcholine. But in addition to that, it also operates every aspect of our autonomic nervous system, both sympathetic and parasympathetic, at the ganglion level. And we have an entire workup of that in Chapter 14. In fact, Chapter 14 is going to look at what we refer to as nicotinic and muscarinic receptor types for acetylcholine. So I'll tell you, we looked outside of the human body to find nicotine and magic mushrooms, and we've discovered that they have an effect at the very deepest level of our autonomic nervous system. Okay, so for the most part, this would be stimulatory, with the exception of the autonomic nervous system that operates the parasympathetic side of things. So most of the time we're thinking of excitatory direct action, but it could be inhibitory, particularly when the vagus has to slow down the heart. So our parasympathetic nervous system calms us down. Now, it's also possible for the sympathetic nervous system to increase blood supply to muscles and to the heart and to the skin. When you're sprinting down the road, you better have a great blood supply to the muscles. And the only way you can do that is through inhibition, which is to say dilation of the arteries. So the artery has to relax and dilate and let more blood come in order to excite the musculature. Okay, so there's sort of a dual thing going on there, especially with a little help from the sympathetic nervous system. So the sympathetic nervous system is peripheral, and as are your skeletal muscles. The central nervous system is involved in various types of brain activity. And so here we have hippocampus, and we have a modification of fine motor control. Okay, so you can get into all of these things over here, and you can stop the music for a moment here and read about, whoa, look at all this stuff. So you can see the complexity of what's going on here. Okay, but we're going to deal with that. Chapter 14, we're going to get deeply into it. Meanwhile, moving right along, we have epinephrine. Epinephrine, of course, represents both the direct hardwiring of the sympathetic nervous system. When you wake up in the morning, you need epinephrine so that you go from parasympathetic tone to sympathetic tone. Your musculature is set for a certain level of sympathetic tone so that your joints work, so you can actually stand up when you leave the bed, right? You don't fall over or anything. So also this is very much an endocrine situation, because more than 50% of a standard sympathetic outflow is blood-borne, not just hardwired. So part of it's hardwired, but then part of it is bloodborne. Okay? Generally speaking, it can be both excitatory or inhibitory. If you want more air coming into your lungs when you're sprinting, you need to dilate those bronchioles. Also, if you need more blood supply to your musculature and your heart, you need to dilate those arteries or arterioles. So it can be both excitatory and inhibitory. Okay, then. So that's our situation with that. Dopamine. Dopamine is always a good time. Excitatory, inhibitory. It involves the use of emotion in many cases. The central nervous system, we have a release of substantia coming from the substantia nigra of the midbrain, and we are going to be acting upon various types of pathways that have to do with motor skills and things like that. But in the absence of dopamine, we have a condition that's referred to as Parkinson's disease, and sometimes fine motor control is challenged, and so people have little vibratory activities in their hands. If you watch them write, they actually have sort of a pizzicato, a little bit of a vibration in their handwriting. If they get excited and try to explain something, sometimes their arms quake a little bit. If you dose your patient with L-Dopa in order to overcome the dopamine deficit, you might